Yeah, we're live. It's Friday night. Hope everybody start off their weekend is going good. We've got a couple of cool things to talk about. One, I posted a video today on part 2 of the testing on the Junkyard Dodge 360 Magnum. So that's awesome. We already ran the header test and we also ran nitrous, as I do always, because it's so easy to do. And it's the thing that I can get done sometimes in the amount of time that I have, rather than trying to do a cam swap and try to rush that and make that happen, because sometimes it takes a little bit longer, especially if you're doing things for the first time. What happens when you're taking apart a motor like that Dodge Magnum is something's going to break. You're going to break one of the bolts off, the gasket's going to tear, you're not going to have another one. Whatever the deal is, it's going to be more problematic than you actually think. So you have to figure on that going in. Not that we already didn't have a number of time-consuming issues just getting the thing up and running and working and stuff. So, but we will have more of that coming. I will have more camshafts. We'll try that. Obviously, we'll try. I've been discussing something with a couple of guys today and tonight, different cylinder heads and different intake manifold combinations and stuff. So we'll probably get that going and run a few different ones, and that'll be cool because we're going to run some dual plane stuff and single plane stuff, because there's some misinformation out there about which ones of those work. Hopefully I can get together with some of the guys that are still making parts and catering to this market, because I'd like to test some of their stuff, some of the kegger manifold upgrades, obviously the inserts to reduce the plenum volume, getting rid of the divider, it would be interesting to test the two different manifolds, one that has the divider and one that doesn't. We can try bigger throttle openings in those, and obviously changing the runner length of those manifolds. We can do all that stuff on the Dodge as well. But there are a couple of different cylinder heads that I want to try. I know that I'm being told that the EQ heads are not the same as they were before. They're not readily available. I'm looking at the Speedmaster stuff. So Speedmaster guys, if you're there watching, I'd like to do some more stuff with you guys. They have both an iron head and an aluminum head version. In fact, I guess technically they have 3, because they also have a CNC version of that head. And it might be interesting to try 1 or 2 of those. I would definitely like to try, the one I'm most interested in actually are the iron heads. And I'd like to try that. I'm told by some guys here that might be here. TCH Inc., I will get back to you. I did check my email. I have the data. I'm just going to send you over the data on the test. I'm lacking some video and photos that I need to finish that story. To finish that video. I wish I could, because I would wanted to get it up a long time ago. But we'll get together and we'll get you those heads back so that you guys can sell those and run them and stuff. So I want to do the iron heads, the Speedmaster ones, if I can't find a set of old EQ heads. The other thing I kind of want to do on the Magnum is I want to try just milling the factory head and then maybe doing a valve job and stuff on it, just doing an update on that factory head and putting it back on, because that's something that a guy would do. And the thing probably needs more compression anyways. I'm sure that the piston's down in the hole, and I'm sure that this is going to be 9-to-1 or less. And so it'd be interesting to find out, if we can gain some power just by milling it and maybe doing kind of a quickie valve job, and hopefully that will work out. But obviously what the thing really needs is, like I said, I want to do the kegger mods, but it needs an intake manifold, and it needs a good set of cylinder heads. And we can make fairly good power, I think, with the stock Magnum heads, but definitely a camshaft and definitely an intake manifold. I've been reading up on some of the stuff that Dulcich and the guys have done in the past. And, I think they ran some fairly big cams in a lot of their stuff. And with the story that I saw that Dulcich did, he actually used Edelbrock heads, and they're in the 430, 440 horsepower range with a single plane intake and those heads and a fairly good sized camshaft, something in the 230 at 50 range. And then the other one I saw that the guys did made like 450 or 460, but they had some again, a fairly big camshaft, a big mother thumper camshaft in it, and an intake manifold, and they reworked a set of the EQ heads. And so, but they also had a different short block with a flat top piston and valve release so they could run more camshaft. So it'll be interesting to see. The other thing that I want to talk about, and the reason that I put up the thumbnail that I put up, is because we want to talk about some turbo stuff. And I've been having discussions via text with another gentleman about some cam testing that they did on the 2.2 liter turbo stuff. And this is the kind of testing that I like and the kind of testing that I want to do. And again, I'd like to do it both naturally aspirated and turbocharged at some fixed boost. But he was talking about changing the cam by moving it one tooth on the cam sprocket. And we've done that stuff back when I was running the first 3-valve modular motor way back in the day. That's exactly what we did. We didn't have the ability to control the variable cam timing. So we did it mechanically, and we just moved it a tooth and then found out what we retarded it, because that's the direction that the factory was going. We retarded it, and it did indeed pick up power as you would expect and lost power down low, again, as you would expect, which is the benefit of variable cam timing. But the gentleman that I was talking to about the variable cam on the 2.2 liter Omni turbo motor, or really any 2.2 turbo motor, he said it had predictable results. That when we advanced the cam, the turbo came up a lot faster. Therefore we know that it made more low speed power. He said, but it obviously fell off at the top. And then the opposite happened when they retarded the cam. It was much soggier on the bottom, so we know that it lost power down there, but stormed much harder on the top. And if we do that test, and obviously the answer to having both of those is to have a variable cam. And he was talking about somebody that had designed a variable cam that was either boost or RPM dependent on the 2.2 liter. So he gave me a link, and I'm going to go check it out. I haven't checked it out yet, but I want to. So I want to take a look at that. But that's a test I'd like to do naturally aspirated and turbocharged, even at a fairly low boost level, because I want to find out what it does NA, and then we can correlate that with, oh, hey, look, it made more power here. So here's what we would expect on the turbo thing. It's going to come up sooner. And if it comes up sooner because we made more power down low, now the turbo is more responsive. And then because it's more responsive, we now have boost at an RPM range that we didn't have it before. So the difference can be fairly dramatic. Like, let's say we made, 10 or 15 more foot-pounds of torque. That can have an effect on the spool rate. And then if you change the spool rate, then all of a sudden, maybe you have another pound or two of boost. And then now, instead of 10 more foot-pounds, maybe you have 20 or 30 more foot-pounds at that same RPM. So it can have a fairly big effect on the turbocharged application. So that's why I like to test it NA and turbocharged, because a lot of people get confused and they go, oh, well, yeah, on a turbo, it wants to do this. But that's not totally what's happening. You see a change NA, and then you see what it does turbocharged, and then that way we have the whole picture basically. But again, obviously the optimum thing would be able to have it one way at one RPM and one way at the other. And after looking at, and Calvin, if you're listening, after looking at some of the data that Calvin has from the 4-valve stuff on the 4200, that the other thing that was happening is, in addition to being RPM dependent, like we would expect, you want to advance the cam down low and retard the cam up top, typically, assuming that the cam is whatever straight up is coming from the factory. But the thing that he was showing in the testing that he did on the 4200 is that when the thing was boosted, it might not respond to the same cam timing that it did NA. Because when I did the 4200 testing, we swept the cam timing and found out where it wanted to be. I didn't do that when it was turbocharged, and I want to see, all we did was run the boost at the same optimum cam timing that seemed to work best when the thing was NA, and I thought that that's a good starting point. What I wanted to do on that application, and what I would do on the 2.2 also, is if we could advance it mechanically, is I would test it NA and then test it like at 7 pounds. And then also I'd like to test it at 10 pounds or 15 pounds, whatever the new higher rate is, and then see if the increase in boost, first of all, see if we have a change. Okay, does it want something different under boost? And then the next question would be, does it want something, again, even more different at a higher boost level? So that would all be really good stuff. And that's all stuff that can happen fairly easily on the engine dyno, because it makes working on the motor so much easier, especially in this particular case on the 2.2 or 2.5 liter Dodge Omni turbo stuff, because accessibility to the backside of that is can be problematic. And when it's in the car, there's not a lot of room. It's much nicer when the turbo is like, up front, right where you can access it and get to everything. It's nice if it's a cross flow head and it's a 4-valve and it's all of the things that you want it to be. It's not always like that though. But I'm looking forward to doing the 2.2. I haven't even taken the motor out of the car yet, so I haven't done that. I'm going to do that fairly shortly here, so I can get that thing taken apart and find out what's going on inside the motor. What is it? Is it a valve problem, a cylinder head problem? Is it a broken, is like, how bad does a piston have to be for all of the thing to be leaking by the rings? I almost suspect something else with the thing not making any compression. Usually when I see that, it's that a valve is stuck open, and it could be that the piston got damaged and bent a valve. It could be that a valve has a piece of the piston stuck in it and is hanging open. And then if it does hang open far enough and the piston comes up, I don't know how much clearance. I know that these motors are non-interference motors, but I just don't know how close it gets if a big chunk of piston is stuck in the valve and it's hanging down when the piston comes up, if it will hit it and bend the valve. And then even if you free the piece after that, then you have a bent valve that is not going to seal. And if it's bad enough, it's not gonna produce any compression at all. So get a lot of cool things to look at. And obviously I get to take the motor out, and the motor and the trans probably will come out together. So I get to do that, and then that will help teach me, and I'm going to take lots of photos, and I like to mark everything while I'm doing this, especially most of the hoses, because this has an inordinate amount of lines and stuff running at various places. So I want to make sure I mark them and know where they all go, so I can put them all back and make sure that I have a starting point that's the same as the one when I took the motor apart, at least, because I haven't tried to start the motor. I'm told that it will run. I kind of suspect that if it does run, it's not going to run very well because it's only going to be on 2 cylinders. So I think it's a good thing that I didn't really start it up and possibly create more problems. So I've got to take that out and take it apart. But once I do it, all of that stuff is probably an easy fix. I already have pistons for it. So assuming that the rods are not blued or that, it didn't lose oil pressure, that kind of thing, that should be a fairly easy fix. And then when I do that, we'll probably have to change the clearance, the piston to wall clearance, just to make sure that it works with the expansion rate of the forged piston as compared to the factory piston, which I think the 2.5 that's in there, I suspect that it's all stock, including the ring gap, at least the bottom end stuff is. Somebody asked me earlier whether or not I knew that what camshaft was in there. I don't know. I'm going on the assumption that it's a stock one for the 2.5 because I think that was a replacement motor. But again, you don't know until you take it apart. And then after I take it out of the car, I can definitely take it apart and we can figure out, which end is which. Well, we can figure out what's going on. I'm excited about putting the 2.5 together because I want to compare the 2.5 to the 2.2. I think that's going to be an interesting study to see how much different it is. And like we were talking about, how much more responsive it is. And so with a 2.5, you probably can get away with a bigger turbo and still have the same response rate that you have with a 2.2 and a smaller turbo. That's just the benefit of the added displacement. Now everybody says, oh yeah, but it's bigger. It's not going to rev. It's not. These things don't rev very high anyways. So that will be interesting. Just like with when we were talking about with advancing and retarding a cam, if we advance the cam and improves the low speed power, which typically they do, that would be even more interesting testing it on an upgraded turbo where it probably has more lag than a stock turbo does. I don't know how laggy these factory turbos are on these. I would suspect that a 2.5 would be less laggy than a 2.2 is. But I don't know if they changed the turbo 2.2 versus 2.5, and maybe they did for different years. Maybe that was kind of the thing, and because I know that they did juggle the turbo sizing and maybe even supplier on some of these Chrysler motors. So yeah, all of that will be interesting stuff. And like I said, I'm very excited. I'm excited about just being able to actually drive around in a little turbo hatch. I went out with my family tonight and we went to dinner. And I was trying to explain to them how exciting it would be. It is for me to have that car and to be able to drive it around. They're just shaking their head. Really, it's a 1985. You know, not everybody gets it, but for me, it's really exciting. So let's see what you guys got going on. Let's see. Let's go back a little bit. When do you suppose you get the 2.2 back? I don't know. I actually don't know if the machine shop has even come to pick that up yet. Lee wants what's your thoughts on E3 spark plugs? They work, but they don't work any better than other spark plugs. I have a question on knock sensors. Having a 6.0 stroker built to replace a 5.3 and an 0.5 Sierra, should I keep them or take them out? If you're putting the factory knock sensors, may hear things that are not there if you put together a different motor, and especially if you have forged pistons, which may have some piston slap noise, because you're going to have more clearance there. So you can put it together and leave it the way that it is with the knock sensors in place and see if that works. But sometimes it doesn't when you change the motor that dramatically. Yeah, the E3 stuff is not, you're not going to, we have never seen, and Westech has tested lots and lots of different spark plugs, and I've tested lots and lots of different spark plugs, and I've never seen any power from any sort of weird V-shaped or, multi-pronged or any sort of specialized kind of spark plug. Come on, yeah, get those likes up there, right, Cam? Let's see. I have an aluminum Speedmaster and send them for porting. What's the 360's compression ratio? I'm thinking it's around 9-to-1. Come on, Terry, get that like button. Australia. Go LS turbos, the LMF 2-liter Ecotech engines. Move both cams 10 degrees on both sides on the center line. Yeah, the variable cam is nice, especially if you have it on both the intake and the exhaust, and especially if they advance and retard it. A lot of times they'll start in a full advance position and then only retard, but sometimes the default position is fully advanced, or as advanced as they will go. Brian, yeah, RGL10 made a cam phaser on the 2.2, 2.5, which slid 2 timing belt pulleys back and forth to rotate the cam, advance and retard. Pretty cool. Let's slid 2 timing belt pulleys back and forth. So I'd like to see a picture of that and see how that works. Is there 2 different feeds going on at once? There shouldn't be. Albie, we can always talk Cleveland's. If you have whatever question you guys have, you guys can ask away and I'll try to answer it. David's really eager to see some dyno footage from the 3800. You and me both. Sometimes the valve seats drop on the 2.2, 2.5s. I've heard that, and that's something that we'll have to look at and see. Dan, we ran a 351 Windsor in super stock, 621 horsepower on 8.68-to-1 compression, open chamber heads. What heads were they? And that was a really, really big camshaft, I'm assuming. Oh, Dan, that makes a lot more sense. Yeah, I was going to say, I don't know what kind of factory head you're going to get 621 horsepower on a Windsor, but a Cleveland makes a lot more sense. Brian, so the 2.5 got the TEO4, the little Mitsubishi turbo. Why would they put the smaller turbo on the bigger motor? I bet it's really, really responsive, though. The 3800 will make power. I know that for certain. Will Edelbrock heads on the Magnum allow more timing advance? So, Nick, here's what I want you to ask yourself. Why do you want more timing advance? You don't, actually. You want the amount of timing advance that the head needs to make maximum power, whatever that number is. More timing is not better. In fact, I would argue that less timing is actually the way to go. Do you think the Okie Speed and Off-Road, do you think the totals timing the 5.9 Magnum wants will change when you change the cam timing or the cylinder heads? The cylinder heads, quite possibly, because a different chamber design can definitely change the cam or change the ignition timing needs. The camshaft, I haven't really seen that. When we do the LS stuff, when we go from a stock cam to a almost, I mean, every kind of aftermarket cam that we've run in there, they all seem to want about the same timing. When we change the heads on an LS to a 317 head, for instance, it usually wants another degree of timing, another degree or two of timing. But I won't say no because I haven't done enough 360 Magnum testing yet. The 455 Buick is, I don't know what it's doing. I need to check with the machine shop and find out. What I'm going to do is the 455 Buick is going to go together as a 1970 stage 1 455, and then we'll test from there. Brian, they wanted low end. They should have got lots of low end with a 2.5 and the and that small turbo. Is it possible to experience boost creep with too large of an exhaust back housing? So you mean the turbine housing on the turbo? I did not bore scope the 2.5. Brian, I'll be interested to do testing both on the engine dyno and on the chassis dyno. So once we put a combination together and test it on the 2.5 and on the 2.2, getting it in the car and running it on the chassis dyno will allow us to get a better idea on what actual turbo response is. Because on the engine dyno, it's an artificial load when we load the motor at 2,000 or 3,000 or 4,000 RPM, whatever the starting point is. And you can just never see that out on the street or, even at the track. Steve, the more timing you need, the less efficient the combustion chamber. I agree with that. Our 4-valve heads make the most horsepower at 26 degrees of timing. Yeah, and this goes way back to old school stuff. They're like, I threw some more lead in it. You know where I have seen this actually work is, and I remember talking to Evan Smith about it, and we run stuff on the engine dyno, and we'll run this is back when we were running like 5-liter Mustang engines, and I was running them, and 35 degrees or so kind of seemed to be where they would make peak power. And again, we're running them fairly cold and stuff, and they seem to work fairly well. And he was saying that on the track they would add timing, and the car would go faster. And I don't know what the curve he had in there, so maybe adding more timing improved the curve, even though it wasn't making what it should be, or it had more timing that it needed at the peak. And if you have enough octane in it and it's not detonating, that might be okay, but you can get to a point where you have too much timing in it and it'll actually start losing power because it's basically igniting and fighting the piston coming up if you have too much timing in it, too much lead in it. But that goes old school, oh yeah, mine runs best at, because everyone says, oh, mine runs best at 36 degrees, and the next guy says 37, and pretty soon you're up to 40, and then whoever the last guy is, that's the guy that wins, and he has the biggest number. But that's not what makes power, though. .351 Windsor, 351 Cleveland, or 460 twin turbo most power. I don't know about the most power out of those would be a 460 based stroker with turbos on it, just because it's going to be bigger and it has more cylinder head that you can put on it and more potential and all of that. I don't know, Shelby, I don't know how much power you're wanting to make, but any of those are way into the 4-digit stuff. Speaking of Cleveland's, can a Cleveland piston work in a 400M with 400 rods? I don't know the answer to that. I don't know what the compression height is. I guess the real question is, where's the 5.9 Magnum happy at for timing? It's happy where we ran it. We tried 27, and at 28 it didn't gain anything. 29 it didn't gain anything, so we didn't go any farther than that. The the chamber design on the Magnum is much better than the LA head. I'm running a 393 Cleveland stroker roller cam. What lifters you recommend? I don't know about the only ones I think that we've run on a Cleveland are from Comp, but I don't even remember which ones we were running. I'd have to go back and look at the data and see what they were, but that's the only experience I have with the Clevelands. I think all of the other stuff that we ran were hydraulic flat tappet stuff. Watched an 87 Terry, watched an 87 Laser 2.2 eat a bunch of head gaskets back in the 90s due to excessive heat and stupidity. When you blow a head gasket, it's usually a tune problem. So it's timing or fuel related. You can blow a head gasket based just on power if the head gasket is weak, but it takes a lot to get there though. Let's see, what was VK's comment? Brian, you might be able to interest Richard Holdner in an LM SMEC harness. And then Brian, only if Richard runs the factory electronics. We're gonna, Brian, we're gonna run the factory electronics in the car. So if you have something clever there, please let me know. Do you know how the load is applied on an engine dyno? I've always wondered, like, is there wear items that need to be replaced? Yeah, the load cell needs to be taken apart, and the absorber too. A lot of that stuff, it wears over time because it's a water break. But that stuff gets checked and replaced all the time, or checked and replaced when necessary. They've even, the guys at Westech have even redesigned parts for the Superflow and made them out of, you know, stainless or whatever's necessary to make it work better, and they've upgraded it. They've done a good job. My mic's still beating the 460 drum there. Have you ever messed with an Audi 2.7 twin turbo? I have not. I do like the S4s though. Is there a way to set up a chassis dyno load and then set up the engine dyno with that load? The problem is you have to have a stationary load to start the dyno run, and you don't ever have that. It's not, you can't do like an inertia run like you can on a chassis dyno. You can do that on a chassis dyno, but you don't do that on the engine dyno. My 2.5 with ported manifolds and a, what is LENGEL plenum? Lengel plenum, and a 50 trim runs hard to 6,000. I would much rather have some sort of standalone, even in the car, but right now it has the factory electronics in it. I just want to make sure everything works in the car. Dan, 4V Cleveland heads flow really well. Ours on the Super Stocker flowed 340 CFM. That is really good. Though all the stock ones that I tested were like in the 275 range. So those are obviously done up pretty well. That's a lot of flow. Yeah, Brian, definitely send me an email. Project Q, my 2.2 stock head with FM 505 MP rockers and a 57 runs hard past 6,000, but I'm not pushing it. The thing that's going to determine where the motor wants to make power is going to be the cam timing and the runner length, and then the head flow. And if you have that stuff, then it will want to run at a different RPM. And then the boost should stay constant if you have a good wastegate. It should say, if you set it at 10 pounds, it should be 10 pounds all the way through. If you can create a rising curve like a centrifugal blower does, you can also extend the operating RPM range of the motor. I believe the Mopar Performance Catalogs used to suggest 40 degrees advance on naturally aspirated 2.2s back in the 90s. It wouldn't surprise me if that kind of timing wouldn't surprise me if the 2.2 was indeed based on the slant 6 head design. How do Magnum heads compare to Ford GT40P heads? I think a Magnum head flows more than a GT40P head. Does it take a lot on the 7 MGTE? I like those motors, Tom. Jeremy is suggesting Morel lifters and the Clevelands. Now, if you're going to go the Morel route, make sure that there are different stages of Morel lifters, so make sure that you look at all of them. Aaron, I love how the Magnum heads are superior to the LA head when it comes to airflow and chamber design, but the old school Mopar guys argue that the one advantage after talking to Dulcich about the LA and Magnum stuff is that the LA head has the ability, because of the shaft rocker, to run an offset rocker, and then that allows you to run a bigger port in the LA head, and then that bigger port would obviously support more power once it's ported. All of that kind of makes sense. I think if a guy's going to do that, he's going to put some kind of aftermarket race head on there anyway. Project Q, convert to 87 CSX electronics and chiptune. The computer that I had that's in the car right now has been modified. It's been depotted or something so that it can be tuned. I haven't taken it out yet to have it looked at to see what it is and what's been done to it, but that's what I was told. What weight do you recommend for a Cleveland? That's going to depend more on what kind of clearances you put in there. It's not Cleveland specific. It depends on more how you put the motor together. I normally use like a 1030 or a 1040 and something like that. But again, if the tolerances are fairly loose, we might go something a little heavier. Steve throwing it back at Mike. Mike, the 460 is dinosaur technology. It makes 650 horsepower with ported heads, though. And then Steve is coming back with the best use for a 460 is to hold a boat in place. Wow, the old anchor joke. So you're saying a Magnum is fine with 87. Are you talking about 87 octane? Yes, Brian, make sure you do. I have spreadsheet instructions to replace the 85 ECU with the 89, which is much faster. And it might already have that in there. I don't know. Chris, are you building a 383 small block Chevy stroker, 64cc chamber, decent fluid head, high 200s, what cam for torque? On a 383, I'd look at something that's like a 224, 232 probably. And look at an extreme energy cam or an XFI cam, something that has, depending on how good that head flows at a higher lift, something that has like, 550 to 570 lift. Yeah, Dan, using that zero weight stuff works good, but it depends. Yeah, I'm sure you guys have set your bearings up accordingly. The lighter the weight, the more power you'll make. That's for sure. For F-150, would you prefer the 5-liter Coyote V8 or the 3.5-liter V6 EcoBoost? Do you have the ability to tune both of those? I mean, can you swap the whole thing in, or are you talking about buying a new vehicle and with each of those running in it? I know. I wish I could. I wish you guys could post pictures to the chat, Tim. Mike says convert to true 87 electronics, not GLHS. I don't know that this is done as a GLHS or not. I'll have to look and see what it is, and I'll have to post it and show somebody. I'll send somebody some emails, and so you guys can look at it and tell me what's there. Three-turner, thinking that a larger exhaust housing allows for more flow to the turbo, minimizing the effectiveness of the wastegate. Actually, it's probably the reverse of that. The more back pressure you have, the more likely that the wastegate is going to be problematic. Thomas, 355 Chevy, 8.8 to 1, comp 202, 16, 202, 16 valve, 64cc aluminum head, 2 TO4E, 50 air turbos, 850 double pumper, 4-bolt main, high nickel block, Gorilla rods. All of that seems like it works, although I don't understand the 16 valve head. Terry, I believe that Mopar Performance suggested a Mallory distributor for carburetor units. I did not want to run the ignition computers. I'm in the Magnum. I'm running an MSD distributor. draw through Quadrajet. Yes, it wouldn't be a complete live feed unless we had the draw through Quadrajet. Thomas Hall, what would be a safe tune? I don't know. I would, when we run supercharged stuff or turbocharged stuff, it's usually 11.5 to 1. And the timing, I don't know. I would think I would try, I might start at 20 degrees or so total timing. And it depends on what fuel you're using. If you're wanting to make a lot of power, I'd recommend E85. If you're wanting 91, then you're going to have to be conservative on your timing. People don't understand the power big block Fords make. Big block Fords make the same power as everything else that's that size. $11.5 to 1 compression. And I like big block Fords. They have good heads. There's lots of good stuff for them now compared to the Chevy. Well, I mean, Chevy has always had lots of good stuff for them. But a 460 Chevy makes as much power as a 460 Ford does. They both can have the same displacement. They both can have the same compression. They can both have the same cam timing. They can both have the same head flow. They can have the same stuff. Where's the Magnum happy at for air fuel? It didn't seem to be too fussy about air fuel. We swept it from, I don't know, as rich as 11.8, and we went all the way up to 13.0, and it didn't seem to make a big difference. So we kept it in the 12.5 range. Project Q, they removed the potting material and socket the board for a removable chip. I think that's what they did. Look into an Ostrich 2.0 technology, pops into the socket before the chip for data logging and more. Okay, cool. Is all of the ECU and the engine bay and the GLH? I honestly don't know. I don't know if it's there, and if there's one in the kick panel too. I haven't even looked. Does anybody know what, for a Magnum, does anybody know what the factory timing is actually in the vehicle? Has anybody logged one, or when they're doing dyno testing and had a tune done on it, do they know what the factory starting point was? I should be out working on my car, but I'm sitting on my butt drinking a beer, watching and learning from Richard. See, you're in class. That's perfect. And we will write you a note if you need one. Low Performance did sell offset keys for camshafts, advanced retard, as well as jet kits for the Weber Holley carburetors on the early 2.2s. I'm wondering if when we try to run the 2.2 turbo up on the engine dyno, if it wouldn't be a good idea for me to use a carbureted distributor on there that we could then control with the Holley. Because I'm thinking that we aren't going to be able to control the turbo version. I run 60-weight Dominator AMSOIL. I would like. I want to check out this DIY variable cam system. I'm very impressed with it. Yeah, Brian. I don't know about where the ECU is. I don't have the car here, unfortunately. Let's see. Draw through quadrojet at 10,000 RPM, at least, right? Yeah, the Magnum combination chamber is kind of heart-shaped. What do you think 350 Vortex generally want? I think that they're like in the, I think that the ones that we were running were like 28 or 29, if I remember right. I'd have to go back and look to verify that, though, but I think that that's where it was. Went high 8 with a 306 Vortex YSI 15 years ago. Looking to change it to twin 94 millimeter. Looking for best combo and reliable. 351 at Cleveland, 351 Windsor, 460. The bigger the motor is, the easier it is going to be for you to make power. What do you think about a lockout MSD distributor on the street? I think it's problematic. If it should have some kind of curve in it, even if just to make the thing easier to start. It does have part of the ECU under the hood. I just haven't checked the kick panel to see if there's something under there too. Jay, I know you're waiting on parts to get the L67 running. Do you already have all? I don't have all the Go Fast parts for the L67, not even close. But we won't run all of those to begin with anyway. But I have a lot of stuff to run on the L67. Dan, your budget 3.3 liter Porsche turbo. Things that should never go be said together. Twin EFR 7163s, 850 at 7,000 is the target. Budget is adding a 0 to the cost of small block Chevy parts. at least one. Are you planning on running E85 on the 360? It'd be a waste of time until we add boost to it because it's not going to do anything. I've not run a draw-through setup. They have run those at West Tech. Ken Croce from he's the Pontiac guy. What's the name of the Pontiac? HO Racing has run a draw-through on a Pontiac with a quadrojet, and so there you go. You get your quadrojet story in there. He did run one on there, but I've never done it. Brian, use a TBI distributor with the Holley. It has a single Hall effect pickup as opposed to the 2 Hall effects on the turbo. Okay. So can I just go buy that at the auto parts store or something? Can you show the difference between a boosted lock VTEC engine and non? Primarily focus on oil pressure and horsepower. I don't ever run locked VTEC motors because it's going to make so much less power down low, and it's going to the turbo's not going to want to spool up if you only run it on the VTEC cams because they're usually fairly big. Now, like on the stock one, so a stock VTEC, like a stock B series VTEC, a P30, like a B16A, the secondary or the VTEC lobe is not huge compared to some of the aftermarket stuff, or even compared to like a Type R. But there's no reason to do that. If you're running a VTEC motor, you should take advantage of everything that it has to offer, and then you should also run boost with that. Mike, I don't hate the 460. I think that they're fantastic. I just think it's like everything else, all the motors make power. Saul, tube length affects power curve same way, an intake manifold and exhaust manifold. Tube length and intake manifold seems to have a more pronounced effect on exhaust manifold. Yes, it does. Because one of them is filling and the other one is extracting, and I think it's probably harder to extract. Draw through works good on VWs. It works the same on VWs as it does on every other motor. Have you heard of Vortec Pros? 467 rebuilds running 049er at 781 heads. An 049 head is a good oval port head. $7,000. That's a good deal. Bring back the draw through Excel turbo kit. I was wheeling and dealing with somebody on one of the old Martin turbo systems, or the Excel one too. Also, I was reading on that, and I was going to try to get one just to test, just to do a gee whiz kind of thing, but it never happened. At a certain point, the VTEC system becomes a liability. So are you talking about like way into the 4-digit stuff? Yeah, Tom, I would agree with that a lot of guys are running, the VTEC eliminator stuff with the rockers on it just for weight, so they can run more RPM. With a bunch of stuff unplugged, the 2.2 computer could be set at 20 degrees at idle and bump timing to 40 at 2,000 RPM. 40 seems like a lot at 2,000 RPM. Twin turbo draw through quadrajets on a 5.3. Yeah, Benjamin, that would definitely trigger people. My grandfather had a quadrajet that was an 800 CFM. I believe he said it came off a W30 Oldsmobile. They used that big one also on Cadillacs, I think. I think that there's another application too where they used it. They kept dropping valves with VTEC at 10,000 RPM. Why would they be dropping valves? Why would if they're on the VTEC cam and it's already been actuated? I do like on Mike's right. I do like on the big block Fords that you can make really big motors out of them, much bigger than you can out of a production big block Chevy. So it definitely has an advantage there. I like the fact that you can make a 557 out of a production block, and you cannot do that on a production big block Chevy. I like the fact on the Quadrajet when I did the test out with Courtney out at the Cadco when we were doing the Cadillac stuff, that he showed me the Quadrajet that they used on the Cadillacs, and that it had a provision in it to sense changes in altitude, which is really cool for a carburetor. They think when the VTEC kicks in, it drops the valve. So the VTEC crossover point is not going to be at 10,000 RPM, I wouldn't think. Terry, I just realized I spent way too much time playing with 2.2s. There's no such thing. I've never done anything with an 8.1 GM. Not yet. Ever test out one of Hector's spoon engines? I haven't. I can't afford Hector stuff, man. He's a baller. Supercharged 65, still waiting for the 292 follow-up. You and me both. Am I all there? I'm all the way down to the bottom of the things, right? Yeah. The other thing that a lot of guys don't realize, and I'm not saying this about Boosted Boys, I love the stuff that they're doing, but when you're doing camshafts and you're running elevated engine speeds, it's not just more spring rate. It's the right spring rate. And it's the right position of the spring, especially when it's fully depressed. Having a certain amount of space between the compressed spring and coil bind. It's also the ramp rates of the cams that you're using. I mean, there's a lot of stuff that goes into running lots of RPM, and it's not just more spring rate. That used to be how we cured everything back in the day. You know, you had a big block and you want to rev it higher, you got to put those, 1,000-pound springs in it. Well, that might not be the answer. And then lo and behold, Spintrons showed, hey, look, this is not the way to do it. When we add spring rate, we're making the situation worse. We're not curing it. So that's when people realize that, hey, cam ramp rates and stability provide an awful lot, especially at elevated speeds. So if you want to make power at higher engine speeds, having the right cam and then having the right spring, and then having the right spring rate, all of that stuff goes together, and it takes a lot. But once you have it right, it's right, and it works. 20B Mazda would be very cool. Light valve train stuff works too. But even light valve train won't save a poorly designed cam profile. Do you have any videos out about the Silver State? I don't. I would have it that those are all done on like VHS or something. Yes, I had hair back when we did the Silver State stuff. That was way back. I think I did my first one in 90. See, I got my car in 88, 87 actually, November of 87. So I ran in the very first Silver State. So whenever that was, 89, I think. Chris, do you think that a 454 Chevy with 600 with good oval ports, the oval ports will definitely support 650 horsepower. So then now you just have to get enough camshaft to it and the right intake manifold, and then that's possible. Mopar Joe is doing a 408 small block Mopar with the older RHSX Indy X heads. I would like to actually go back out to Bonneville with something kind of unique. What differentiates one cam manufacturer from another with the same spec camshaft? Just because they have the same lift and duration and even lobe separation angle doesn't mean that the cam's the same. The ramp rate of the cam can be dramatically different from one manufacturer to the other. Their finishing procedure, there can be a lot of differences between different camshafts. And especially if you just designate them stage 1 or stage 2 or stage 3, they could be dramatically different. I've seen lots of tests on the Spintron and from customers, unfortunately, too, where they've run camshafts that guys are saying, and this is a fairly common thing anymore in the industry, is like, hey, our cam makes the most power. Yes, it does. But it only lasts for about 5,000 miles in the car because it beats everything to death. Yes, it's got super aggressive ramp rates, but it's lofting everything. It's bouncing everything. It's killing lifters. It's killing the valve tip. It's just, it takes a lot to make it work. It takes a lot more than people think. When we were running stock eliminator, the cam manufacturers, this is from Dan. I love this stuff. When you were running stock eliminator, the cam manufacturer said the cam would float all the valves at 6750, and at 6751, all 16 seemed to float at the same time. That's pretty good. That means that the guy did his homework, obviously, and has tested that before. Yeah, Mike, actually Friday nights are not good. I don't get nearly as many people watching as I do normally on other days. Casey, I did know Terry Herman. He was a great guy. He was a driving instructor, and he was a heck of a driver too. Drove in the 24 Hours of Daytona. And I was there when the 959 clone went off. That was a sad deal because Terry was a really great guy. He also drove a friend of mine's car, a Turbo Trans Am, the one with the Grand Nationals in it. And actually, they're the guys that told me, "Hey, Richard, you're not going to finish the race if you don't put extra fuel in it." And so I had lots of fond memories. I drove with Terry up at the Virginia City Hill Climb put on by the Ferrari Owners Club, and he brought that Trans Am up there, and we were kind of fighting it back and forth to try to get the fastest time. He ended up winning because he was a much better driver than I was. But he was a lot of fun, and he was a great guy. Yes, a Lark for the salt. Those were popular back in the day. Yeah, Aaron, I was talking to somebody else about this today about people not getting notifications. I don't know what the deal is. I don't know if I'm doing something incorrectly on my end for the people not to be getting them. I mean, obviously have lots of subscribers, and they should all be here, right? There should be 167,000 of them, right? Casey, I have seen that 36 horsepower challenge with the VW stuff. I think that would be interesting. I'd actually like to work with somebody on a VW motor like that. I did some stuff with runner length on VWs that surprised a lot of guys that were that they were specializing in Volkswagen power, and we showed them how to make more average power. The Avanti was also very popular out at Bonneville because they were fairly aerodynamic. Oh, Casey, so you got some stuff from a yard sale that they're having. Okay, I got a minute and a half left. Yeah, a lot of those early cars had like that they set records in. I think Granatelli set records in the Avanti. Okay, Jay, you get the notification, so you need to go online and tell everybody else when it's happening. It's not like we don't do it at 7 o'clock all the time. Anime fun. Hey, so several decades ago, my old man and me made a NA 2.2 on an 89 Dodge Daytona on nitrous. So let's see. I want to go back and ask one more question. This will be the last question, and it'll be my question. See if he's still here. I haven't seen him chime in. I'm scrolling back. Brian, are you still here? If you are, let me know about factory camshafts on the 2.2. I know that when they were doing the HO versions of the naturally aspirated 2.2s, like Shelby was doing that for the Charger, did they put a camshaft in it that was better than the TPI camshaft? Is there an NA camshaft that's better than the turbo camshafts? So if so, let me know. And I would I don't know how I'd get a hold of one of those, but I would like to try that. And that's not unusual for manufacturers that have a camshaft on the NA motor where they have more compression and they have a little more camshaft to make the NA combination work. And then because it's easy to make power with a blower or a turbo, they kind of detune the turbo version, especially back then, where they drop the compression out of it and probably put a milder cam in it. So that's the case. Let me know so that I can maybe try some other factory cams in addition to running. We want to run at least 1 or 2 aftermarket cams to see, you know, how cams do on these. And obviously I'd also like to run a ported head on it. Yes, Andy, Gail Banks also did stuff with the Studebaker. Ron, you're right. I believe it's a 568. Brian, the 88 TBI seems to be the best. Okay. Let's see. Kyle, thank you for the Magnum 360 testing. I've been driving a 92 Dakota for 21 years. Please retest exhaust manifolds once the engine is cammed. Okay, well, yeah, we can run that again. And I'm also, somebody is sending me a set of the 92, I guess. There's a 2-year variant where they made bigger exhaust manifolds. So we're going to try those versus the ones that I have, because apparently the ones that I have are the small ones. And so we can try that and see if there's any additional power to be had there. And then we can, you know, continue accordingly. I think once we get going with the carburetor and stuff, that we probably will just continue with the headers. But I would also like to try a different set of headers. Those seem to be fairly big, but those are the small block Mopar headers that they had at Westech. They have umpteen bajillion of them up there, and those are the ones that we could find. So I might try to get a smaller set from Hooker, because I doubt, other than a guy doing a 408 stroker or some kind of race deal, that, and it might be that, like we've seen before, 1 3/8 inch, 1 3/4 inch, and 7/8. Maybe there's no difference in power from the headers. We've seen that a lot too. Oh, Casey, I may have another Terry Herman Memorial dash plaque from when I used to autocross in Vegas. That's cool. I think I have one of those somewhere. I think I have the plaque. I think I have it in the 240Z that I have. I'm going to change the turbo on the 2.2. Yeah, we're going to test a few different turbos on it. And we'll do modern cams in it too. I may even go off menu and have the guys from Schneider regrind cams for me to see what we can do with that. Okay, guys, I have to get going. It's Friday night. It's time to party, right? Thank you guys for showing up. Make sure, if you have not, take a look at the video that I put up, and then I'll have something else going up tomorrow. Have a good weekend, guys.